Can you hear me?
Yes, ma'am.
Yeah. Had food? Okay. So, which are the laws that we discussed in the last class?
Law of conservation of mass and law of definite proportion.
Yeah, law of conservation of mass and law of constant proportion or law of definite proportion. And I already mentioned about Dalton's atomic theory, right?
You were going to discuss.
Yeah.
Ma'am, you told you are going to discuss it.
Yeah. So we are going to learn Dalton's atomic theory. Okay. After the laws of chemical combination, we are going to, all of you please switch on your cameras. Okay. So we are going to learn about Dalton's atomic theory. The atomic theory was, okay, Dominic, proposed by John Dalton, okay? John Dalton. So, here, here it is John Dalton. So, according to Dalton's atomic theory, all matter, whether an element, a compound, or a mixture, is composed of small particles called atoms, okay? All matter, whether an element, a compound. Element and compound belongs to which category? The last class or last chapter? Elements and compounds. Which category? Did you remember?
Homogeneous.
Homogeneous, that's okay. But they are belong to?
Pure substances.
Yeah, pure substances. So, all matter, whether an element, a compound, or a mixture, is composed of small particles called atoms. That's the main theme of Dalton's atomic theory. Okay? Shall I move to the postulates of Dalton's atomic theory? Shall I move, Minha?
Yes, ma'am.
Yeah. So, the 6 postulates of Dalton's atomic theory. There are 6 postulates. What do you mean by postulates? Suggestions, okay? Suggestions or points, main points related to Dalton's atomic theory. Revu,
Yes, ma'am.
can you read the first point?
Yes, ma'am. All matter is made of very tiny particles called atoms.
All matter is made up of very tiny particles called atoms. What do you mean by matter? Wait. Anjali Priya,
Yes, ma'am.
what do you mean by matter?
Anything that occupies space and has mass and
Very good. Anything that occupies space and has mass. Examples? Gauri, give example for a matter.
Plants.
Yeah, plants, animals, air, stones, everything around us constitutes the matter. So, all matter is made up of very tiny particles called atoms. This is the first postulate of Dalton's atomic theory. Okay? Then, Elsa,
Yes, ma'am.
yeah, please switch on your camera. Yeah, read the second point.
Atoms are invisible particles which cannot be created or destroyed in a chemical reaction.
Yeah, atoms are indivisible particles which cannot be created or destroyed in a chemical reaction. Okay, atoms they not able to divide it into further and which cannot be created or destroyed in a chemical reaction. We already learned the law of conservation of mass, right? According to the law of conservation of mass, mass can neither be created nor destroyed in a chemical reaction. In similar way, atoms are indivisible particles which cannot be created or destroyed in a chemical reaction. This is according to Dalton's atomic theory. Okay? Then the third point, third postulate. Adulya? Yeah, read the third point.
Atoms of a given element are identically in mass and chemical properties. Law of conservation of mass.
Identical in mass and chemical properties. Atoms of a given element are identical in mass and chemical properties. What do you mean by identical? Similar or same, right? So the mass and chemical properties of all elements means a particular elements, atoms are identical in mass and chemical properties. This is also mentioned in the law of conservation of mass. Okay, clear? Atoms of a given element. If we take an example, hydrogen as a element, atoms of hydrogen are identical in mass and chemical properties. Clear? Is this points clear? Yes or no?
Yes, ma'am.
Yeah. So, well, are you there?
Ma'am, can you show that last slide once more?
Yeah. So, well, please unmute.
Yes, ma'am.
Yeah. So, shall I move to the next slide?
Yes, ma'am.
Yeah. Read the first point. That means fourth postulate. Okay, soil. Where is soil?
Atoms of different elements have different masses and chemical properties.
Yeah, atoms of different elements have different masses and chemical properties. That means the masses and chemical properties of hydrogen is entirely different from oxygen, and it is entirely different from nitrogen, helium, lithium, etc. Clear? That's the fourth postulate. Atoms of different elements have different masses and chemical properties. Then the fifth postulate, Devasena. Devasena. Are you there? Amarin? Shania?
Ma'am,
Why don't you switch on your cameras? Okay, Shania, are you there?
yes, ma'am.
So please read the fifth point.
Atom combine in the ratio of small whole numbers to form compound.
Yeah, atoms combine in the ratio of small whole numbers to form compounds. That is already mentioned in the law of constant proportion, right?
Yes, ma'am.
Yeah. So atoms combine in the constant ratio, okay, to form compounds. Then the sixth postulate. Okay, Dominic has certain problem. Melita, are you there? All of you, please switch on your cameras, okay? Sean, Sovel, Emerin, Jesslyn, Devasena, Shania, Srihari, Dominic, Ahlam, Fatima, Bastin, Karthik, Kshetra.
I'm having network issues. That's why I'm not able to turn on.
Okay, Melita. So, Sania. Sania. Yeah, read the last point.
The relative number and kinds.
The relative number and kinds of atoms are? It's okay, are constant in a given compound. The relative number and kinds of atoms are constant in a given compound. It means when we take an example for a compound as water, H2O, all the water molecules are made up of this hydrogen and oxygen atoms, okay? And that is the kinds of atoms are constant. Hydrogen and oxygen react to form water. And in the similar way, the relative number of the atoms, here 2 hydrogen and 1 oxygen, it is also remain constant in every water molecule. Clear? That is, the relative number and kinds of atoms are constant in a given compound. Okay? So, these all are the 6 postulates of Dalton's atomic theory. Abin,
Yes,
please
ma'am.
read all these points, all 6 postulates. Okay.
All matter is made of very tiny particles called atoms.
Yeah.
Atoms are indivisible particles which cannot be created or destroyed in a chemical reaction.
Okay.
Atoms of a given element are identical in mass and chemical properties.
Okay. Then,
Atoms of different elements have different masses and chemical properties.
okay.
Atoms combine in the ratio of small whole numbers to form compounds.
Yeah.
The relative number and kinds of atoms are constant in a given compound.
Okay. That's all about the postulates of Dalton's atomic theory. Okay. Then we are moving to the next topic, atom. Okay, have you ever observed a mason building walls? Yes or no? Have you observed?
Yes, ma'am.
Yes,
Yeah.
ma'am.
So what's the basic unit of that building or wall?
Ma'am, bricks.
Which one? Brick, right?
Yes, ma'am.
Yeah. Or a piece of sand. In similar way, all the matter is made up of the small particles, or the basic unit of all this matter is known as atoms. Okay, clear?
Yes, ma'am.
Yeah. So then we are going to learn about these atoms. So the first point is that atoms are building blocks of all matter. Okay? Atoms are the building blocks of all matter. According to modern atomic theory, An atom is the smallest particle of an element which takes part in chemical reaction. Okay? According to modern atomic theory, atom is the smallest particle of an element which takes part in chemical reaction. Okay? Atom is the smallest particle of an element which takes part in chemical reaction. And atoms are very small and which can't be seen even through very powerful microscopes. Atoms are very small, which cannot be seen even through very powerful microscope. And the atomic radius is measured in terms of nanometers. Okay, nanometers, nm. Atomic radius is measured in nanometers, and the 1 nanometer is equal to 10 raised to minus 9 meter. That is too small. 1 nanometer is equal to 10 raised to minus 9 meter. That is 1 by 10 raised to 9 meter. 1 nanometer is equal to 10 raised to minus 9 meter, or is equal to 1 by 10 raised to 9 meter. Clear? Is this clear for you?
Yes, ma'am.
Yeah. Then look at this table. When we compare the radius of hydrogen, water, hemoglobin, sand, ant, and watermelon, when we look into the radius, here the radius of watermelon 10 raised to minus 1. Okay, and when we reach at the atom of hydrogen, it is 10 raised to minus 10. So compared to a watermelon, the atom of hydrogen is too small. Okay, clear? Clear? Adulya,
Yes,
is this
ma'am.
clear?
Yes, ma'am.
Yeah. So that's about atoms. According to the modern atomic theory, an atom is the smallest particle of an element which take part in chemical reaction. Then atoms are very small and which cannot be seen through even a powerful microscope. Then atomic radius is measured in nanometers. 1 nanometer is equal to 10 raised to minus 9 meter. Clear? Then next I have a question for you. Yeah. If atoms are so small, right? So it's insignificant in size. Then why should we care about them? Atoms are too small. Then why should we care about them? Ashik,
Yes, ma'am.
any answer? Atoms are too small. Then why should we care about them? Any answer? No?
Ma'am, let me think, ma'am.
Not clear.
Because we are the basic particles of
Yeah,
making
very
any
good.
matter.
Because it is the basic unit of every matter. So we can't able to see, but it's an important factor. If atoms are so insignificant in size, why should we care about them? This is because our entire world is made up of atoms. We may not be able to see them, but they are there and constantly affecting whatever we do. Okay. We are not able to see them, but they are there and constantly affecting whatever we do. Okay. Then we already learned that we cannot able to see these atoms even through powerful microscope, right? But through the modern techniques, we can now produce magnified images of surface of the elements showing atoms. Okay, here it is the image of silicon. Okay, silicon surface, and through the modern techniques, we can now produce magnified images of surface of the elements showing atoms. So, it's clear? Minha, is it clear?
Yes, ma'am.
Yeah. Then we are going to learn the modern day symbols of elements. Okay? Modern day symbols of elements. Are you familiar with the periodic table? Lakshmi Nanda,
Ma'am.
are you familiar with the periodic table? Yes or no?
Oh, ma'am.
No. You just wait. Is this visible?
Yes, ma'am.
Yeah, this is the model of a periodic table. When we look into this periodic table, there are certain alphabets, right?
Yes, ma'am.
Yeah. Here H stands for hydrogen. This is the method of representing the elements in modern periodic table. Okay. We are going to learn about the Daltons symbols for the elements. Then later we will come to this modern periodic method. Okay. This is just to familiarize. Okay. So we are going to learn Dalton's method of representing elements. Okay. So, modern day symbols of elements. Dalton was the first scientist to use symbols for elements. Dalton was the first scientist to use the symbols for elements. And this is the symbols of elements as proposed by Dalton. Okay. How the hydrogen is represented here? Shown.
Ma'am,
Yeah.
like a dot.
How hydrogen is represented according to Dalton?
Ma'am, a circle, a dot in a circle.
Yeah, very good. A circle with a dot, right? But in the modern periodic table, it is represented as H, right? This is Dalton's representation of symbols of the elements. Hydrogen, it is a circle with a dot. Then look at phosphorus, copper, gold, carbon, sulfur, lead, platina, oxygen, iron, silver, mercury, etc. Okay. Then later, Berzelius, he suggested that the symbols of element should be made from one or two letters of the name of the element. Okay. Berzelius suggested that the symbols of elements should be made from one or two letters of the name of the element. So Dalton suggested this type of representation, and later Berzelius suggested that the symbols of elements should be made from one or two letters of the name of the element. Clear? Alna Rose?
Yes, ma'am.
Yeah, please read these points. Modern day symbols of elements.
Dalton was the first scientist to use the symbol of elements.
Yeah.
Berzelius suggests
Yes.
the symbols of elements should be made from one or two letters of the name of the element.
Yeah. Dalton was the first scientist to use the symbols for elements. Later, Berzelius suggested that the symbols of elements should be made from one or two letters of the name of the element. Okay, clear? So, Elsa.
Yes, ma'am.
What is the basic unit of matter? Elsa, are you there?
Yes, ma'am.
Yeah. What is the basic unit of matter? It is the building block of matter.
Atom.
Yeah, atoms. And atomic radius is expressed in which unit? Swati? Swati, atomic radius is expressed in which unit? Swati is not here. Okay, Jocelyn?
Yes, ma'am.
Atomic radius is expressed in which unit? Which unit?
NM.
Which one?
NM.
NM representing what?
Nanometers.
NM. What do you mean by NM?
Nanometers.
Yeah, nanometers. Atomic radius is expressed in nanometers. And 1 nanometer is equal to how much meter? Minha?
10 raised to minus 9.
Yeah, 10 raised to minus 9 meter. And do you remember the postulates of Dalton's atomic theory? 6 postulates. You should read for the next class, okay? So, today we learned about law of chemical combination, law of conservation of mass, law of constant proportion, then Dalton's atomic theory, postulates, then atom, and modern day symbols of atoms. Then you have to do a homework. Page number 32. Page number 32. 1, 2, 3, 4 questions. If you have any doubt, please do message or call me, okay? Okay.
Page number 32.
1. Page number 32 questions. 1. Then page number 33, 2, 3, 4. Don't you see that?
Yes, ma'am.
Yeah, clear.
Yes, ma'am.
Yeah. So let's take attendance. Adil Muhammad.
Not in this class.
Yo, sorry. Wait. Abin Thompson.
Present, ma'am.
Ahlam Fatima.
Present, ma'am.
Alna Rose. Ananda Krishna. Anjali Priya.
Present, ma'am.
Ananda Krishna, are you there? No. Okay. Anthony Maxi. Arun Bhaskar. Ashik Joshi. Adulya.
Present, ma'am.
Bastin. Devasena. Dominic. Elsa. Emery.
Present, ma'am.
Emery.
Present, ma'am.
Pagat. Gauri Nandana.
Present, ma'am.
Gautam. Jerlyn.
Present, ma'am.
Jesslyn. Joel.
Present, ma'am. Jocelyn.
Yeah. Justin. Joel, are you there? No. Okay. Justin. Karthik.
Yes, ma'am.
Kshetra.
Present, ma'am.
Lakshmi Nanda.
Present, ma'am.
Melita. Minha.
Present, ma'am.
Revu.
Present, ma'am.
Tania.
Present, ma'am.
Shania.
Present, ma'am.
Sean.
Present, ma'am.
Sovel.
Present, ma'am.
Sriram. Srihari,
Listen, ma'am.
Swati Krishna, Swati. No? Okay. So study well. Do your homework. Yeah, mail it down. Yeah. Okay. See you next class. Okay.
Yes, ma'am.
Okay. Bye. Thank you all.
Thank
Thank
you,
you,
ma'am.
Thank
ma'am.
you, ma'am.
Thank you, ma'am.